It feels like I've been working on my biosensor project for ages, but finally it is looking pretty interesting. How about you?
Lately, I've been studying neurodegenerative conditions.
That's some bad luck. Actually, you little guy just gave me the best idea.
I think you're going crazy. What is your great idea?
I know that trying to study neurodegenerative diseases is really difficult, right? I think that the biosensor I've been working on could make your life easier. Did you know Drosophila melanogaster, aka the fruit fly, is one of the most used modeled organisms in science?
Of course. I've been using genetically modified lines to study neurodegenerative diseases to come up with possible treatments.
Yes, and which technique do you use?
Why are you looking at me like that? We mainly use Gal4/UAS systems.
Exactly! You use the transcription factor Gal4 to induce the expression of target genes. I'm not sure, but I think I can adapt my biosensor to detect Gal4.
But how can we make it work?
We will begin with an electrode. Then, we will have to design a set of oligonucleotides that form a structure containing the Gal4 recognition site and bind to the electrode's gold surface. Electrochemical testing is necessary to characterize and functionalize it. If you add a sample that has been treated with the Gal4 UAS system, the biosensor could detect the Gal4 transcription factors expressed there. It seems pretty simple, but designing a stable structure in the proper conditions for the protein binding is gonna be a challenge.
It sounds great, Carlos, but how does this relate to my work with Drosophila and the human brain?
If you are using Gal4 UAS as a gene-inducing system, you can relate the amount of Gal4 present in the tissue to the expression of the desired gene. For example, Huntington in the case of Huntington.
That's nothing new, Carlos. There are already several techniques to detect or quantify transcription factors, right?
Yes, but the existing quantification methods for transcription factors are very time-consuming, and in some cases, they are qualitative or semi-qualitative. Also, they are very expensive, and to use those type of equipment, you need trained technicians. My idea of an electrochemical biosensor allows you to quantify the analite, providing faster results and relatively low cost.
And how reliable would this system be?
Since electroactive contaminants are rare in biological samples, living organisms like Drosophila wouldn't be a challenge.
I see where you're going. If we could know how much the genes are being expressed before it is noticeable on the tissue, our work would be so much simpler. Imagine finding a relation of gene expression with its physical symptoms. You're such a genius, Carlos. Let's get started.